Hello, my name is Matt Brown, and today I'm going to be showing you how to find UART on an embedded Linux device that I found at Goodwill. So we're going to head over to the desk and jump into that. So here I've already taken the device out of the case. We can see right here the case, and yes, did buy this at Goodwill. It's a great place you can find all sorts of hardware for doing hardware hacking on. And so took it out of the case already, and we're going to take an initial look at this circuit board. So the first thing I do when I'm trying to find debug ports on a board like this is just to look at it. So I'm going to look at the top, and I'm going to look at the bottom. It's a little easier to see what might be interesting here because there's not as many chips on this side. And so there's a couple things we can look at here. I see a set of places where pins could be connected. On this side over here, we got 9 pins there. And then over here, we have 2 sets of 4 pins. And this looks most interesting to me. If I had to guess, this over here looks like JTAG, and this over here looks like UART. Now, why do I say that? So, UART is minimally going to use 4 wires. It's going to have a voltage line, a ground, and then a transmit and a receive line. Hence the 4 spots right there. And the voltage one is one we usually don't care about, but we will still hook up that connector. So the first thing I'm going to look for on a board like this is I'm going to look for some place where I can find ground. So what I'm going to do, I'm going to put my multimeter into connectivity mode. So here it will beep when something is connected. So common place you can find ground is going to be if the device is wireless. One cool hint is that the wireless antenna is usually going to be connected to ground, but this is not a wireless router. So I'm going to look on this connector here. So I'm going to guess one of these. I'm going to guess this back connector is ground. And the way I'm going to validate that assumption is I'm just going to go and touch some other things around the board to see if they're connected to this. So let me try over here. Okay, nope, that doesn't look like it's it. I'll try this connector. Okay. That's interesting. Let's see if it's connected to anything over on where I suspect UART to be. It is. Okay. So now I believe we found ground over here. It looks like it's these pins. This is really interesting. On this board, it looks like the UART is set up in parallel. In fact, we can validate that this is just like a doubled up connector. So those 2 pins are connected. Yep, those 2 pins are connected. Those are connected. And that last one is connected. So now we have our ground. So we know that ground is this top pin. So now I'm going to go ahead and switch to voltage mode. And I'm going to plug in this thing's adapter. So we'll turn, I guess we'll leave it off at first. And then we are going to take a voltage reading when it turns on. So when we're looking for UART pins, so we know this top one is ground. So that's where my black lead's going to go. And then I'm going to test out these other ones, and I'm going to be looking for 2 pins specifically. I'm going to be looking for a potential transmit pin from the board, and if the UART is transmitting data over that pin, what I'm going to see over here on the multimeter is I'm going to see it fluctuate, the voltage fluctuating as data is being transmitted. Oftentimes a device like this, especially like if it's a Linux device, when it's booting up, it'll be transmitting data, like all the kernel messages that you see on a Linux system when it boots up. Those will all be transmitted over UART. So we should see a lot of activity, especially around the boot up process. So that's why I'm going to test this first pin here. And then I'm going to simply turn the device on. See, it goes to 3.2 and it's just kind of hovering. Yeah, around 3.3 volts. That's a very common voltage for UART. Okay, didn't see much activity there. So we're going to turn it off. And then I'm going to go to the next pin down. And I'm going to turn it on. And there we are seeing some fluctuations between a low signal and 3.3 volts on the high end. So that is very likely going to be the transmit pin on the board that we would connect to the receive pin on our USB to UART adapter here. So it looks like we have a candidate for the transmit pin. And then the receive pin on the board is going to be kind of hard to find out because it's going to look just like the voltage pin, because the voltage pin will just stay at 3.3 volts, and the receive pin, when it's not being controlled by the transmit on some other device, it's just going to stay high at 3.3 volts as well. So now we are going to get our board ready, and I'm actually going to solder some of these connectors up to our potential UART, and we're going to see if we can get a shell on this device. Okay, so now we are going to attempt to solder our pins into this spot on the board. So what I'm going to do is I'm going to actually hold this in place with my pliers, because pesky gravity is going to want to make it fall out. So we're gonna drop that into place, hold it there, and then going to just attempt to get some solder. Where is it? It's underneath, of course. All right. Yeah, this is gonna be interesting. I'm just gonna drop some solder onto this spot. What a fail. All right. This is where I could really use a third hand. Okay. But as sketchy as that was, I think I've got it to stick in place, which is the hard part. Now the rest of the soldering will be easy, because I can use one hand to hold the solder and the other my soldering iron. So now we're going to have some good soldering practices. So we're going to heat that up, heat the pad, heat the pin, and then hopefully apply solder, get it to melt. Of course, I don't have my filter turned on right now. Okay. trying to heat up both at the same time. I don't think these pads are very good on this connector. And I also don't want to heat up the other part of these pins too much, because it has that plastic connector on the other side that can melt if it gets too hot. Which, if it melts and it stays on, that's okay. Okay, let's look at that. This definitely does not have a good solder connection. Right here, this pin. There we go. Wait, it's not actually connecting to the pad. There we go. There we go. And the first one. There it is. We now have our connector soldered onto that board. So if we remember, we believe that the top is ground. So I'm going to flip it over that way. So I'm just going to rip off 4 of these cables. Actually, we don't need 4. We just need 3. We'll use these ones because the white and the gray colors are really hard to tell apart. So I'm just going to make this up. I'm just going to say... So we still don't know. We believe the third pin is the transmit off the board, but we don't know if pin 2 or 4 is that receive pin, so we're just going to guess. We're just going to guess that it's the other middle one, and if that guess is wrong, we will figure that out later. So I'm going to connect that into this cable. We will look right now at the pinout of that cable that I have here over on my screen. So this cable that I have is just a really standard USB to UART serial adapter. It operates over 3.3 volts, which is what we discovered the UART on this board is. Yeah, just again, very standard USB to UART cable. And here's the pinout of the cable. So this is what's important. The ground is black. And then TX and RX are the other signals that we will need to get from the board. And we'll want to note that this is the TX, so orange is the transmit of the cable. So the transmit of the cable should connect to the receive pin on the board and vice versa for the RX from the cable. Whoops. Let's hit back there. So we're going to go back to the desk. And we're going to hook up our cable. So this top one, my green cable here, is ground. So we're going to connect that up to black. And then we believe from that voltage fluctuation we saw on orange that is the board's transmit, and so that needs to go into the receive, which is yellow on the cable. And then we're not sure about this one, but we think this might be the receive pin on the board. So we're going to plug that into the transmit of the cable, which is orange. So now that I've got that hooked up, I can go over to my computer, and I'm going to open a terminal. And you can use Minicom, Picocom. So this is just a program that is going to interact with that device. I'm going to make a bunch of assumptions about this device. I'm going to assume that it's using the most common baud rate. This is like the data rate that is going across that cable. And then on Linux, that's going to show up as dev TTY USB 0. Or if you have more of them, it'll be like USB 1, USB 2, etc. So I'm going to hit enter, and it's going to open with all the default UART configurations on there, and then I'm going to go ahead back at my desk, and we're going to plug this back in. I'll just turn it off to start, and then I'm going to turn this on, and we'll switch back over to the computer and see what happens when we turn it on. So when we turn it on, we are definitely seeing some data. Okay, that's interesting. but we're seeing a bunch of junk. Again, that's really fascinating. So this could be for a number of reasons. This could mean that we have the baud rate wrong, that assumption of the baud rate, I'm going to exit out of this, 115.200 is wrong, so this could be wrong, and it could be a different baud rate. Or I could have messed up my soldering job somewhere. There's a whole number of reasons why this could be occurring, but let's test out the baud rate first. Okay, so now we are going to attempt to figure out what the correct baud rate is on this device. So I just had to do a little bit of research, and I remembered that Picocom or Minicom, they have this feature where you can cycle through the different like default baud rates by going up and down. So from 115.200, it's probably going to be down, so I'm going to use these keyboard shortcuts to attempt to go through those different options. So again, I'm going to turn the device on, it's going to get really noisy, and I'm going to do Control A, Control D to go down in baud rate. Oh. Oops, I forgot. I set it low. So now I'm high. So now I'm going to use Control A, Control D to go down, and look at that. We found the baud rate. So you can see now I'm getting nice clean text, and it says that the baud rate is 57600. So this is our new baud rate. I'm going to exit out of Picocom. By the way, exiting out of Picocom, you do Control A, Control X is what exits you out of Picocom. So now I'm just going to set it to run by default with the correct baud rate, and then I'm going to turn the device off. Actually, I'll exit again. We'll just get a fresh terminal here, and from the start, I'm not gonna hit any keys or anything like that. I'm just gonna see what happens when this device boots up. So we can see it's running U-boot. That is a typical embedded device bootloader. And now we are getting a bunch of other really interesting output. I'm seeing mentions of BusyBox in here somewhere. This is very interesting. There's somehow like automatically entering a password, and it says the password is too simple. That's really interesting. Password admin was changed by the user root. Fascinating. Okay, this is my first time looking at this device live on this video. So now I'm going to hit enter, and I get response from the shell, and that means that I guessed correctly on the pin that was the transmit, or excuse me, the receive pin of the board. So if we go back over to our board really quick, so now we have correctly identified the pin out. The top pin, this the green wire here is connected to. That's our ground. That was pretty easy. We knew that. Then blue here, this is the one that we guessed was the receive pin on the board that we are connecting up to the transmit pin on our cable to transmit. So when I hit enter, that signal gets transmitted from the cable to the board. And then obviously the output from the system comes out of the transmit pin, which is connected up to purple here, and back to the receive pin of our cable. So let's go back to that terminal and look at what fun things we could do to this device now that we have a shell. So if I hit enter, oh, fun. So there's not even a login to this system. So that's it. Right, just like that, I'm given a root shell. This is the first time I've ever looked at this device. Here's this device's, serial number, revision number. Yeah, there's always all sorts of interesting information you can glean from what gets logged in this whole startup process. But this is really fascinating. And that is going to be it for our first video. Thank you for watching, and please like, comment, and subscribe. Please comment below and tell me what you liked, what you didn't like, what you would like me to look at in the future. I'm going to continue to do more videos on the topic of IoT security, and so I would love to have feedback for the things that you find interesting. Thank you and have a good day.